In this problem, we're told to use this substitution, u equals 3x minus 2, with this integral, the integral from 0 to 3 of sine of 3x minus 2 dx. So we're going to rewrite this integral, which is currently a function of x, in terms of u. So we'll have a function of u here. So this obviously, the 3x minus 2 right here will become a u. But we also need to replace this dx with an expression involving du. And we also need to replace these x values, 0 and 3, with values of u. The fact that this is a function of x and a dx implies that this is x equals 0 and x equals 3. So let's replace all of these things with expressions involving u. So I'll start with this equation for u and simply take the derivative. Du dx is simply 3. That's really easy. And then from that we can find an expression for du. Du is 3 dx, or we can solve it for dx. Dx is 1/3 du. So I'm going to put a u right here in place of the 3x minus 2, and I'll put a 1/3 du right here in place of the dx. But I also need to think about the lower and upper limit of integration. This 0 right here is an x equals 0, and if x is equal to 0, then u is 3 times 0 minus 2, which is just -2. And if x equals 3, then u is 3 times 3 minus 2, which is 7. So my original integral can be written as the integral from u equals -2 to u equals 7 of the sine of u, and then instead of dx we'll write 1/3 du. Now the 1/3 will come out front, so this will equal 1/3, and then we have the integral from -2 to 7 of the sine of u du, and that's the answer. This -2 and 7, we don't have to write u equals -2 and u equals 7. The fact that those are u values is implied from the fact that this is a function of u and a du right there. So that's the answer.